like to see, well, actually, we'd like to hear a little bit of the responses here. Now, I think you'll think this is kind of cute. We're actually going to listen to some of these. We will not know who it is. So if it's really good, you'll sort of just be the secret student. If maybe it's not really good, nobody's going to know the difference. But forgive me a second here. I get this set up. All right, I hope this works. So here's what some beloved student said. Hold on a second. It's a lot to try to do here. All right, this is what some beloved student said.
YR of 140 degrees is equal to 0.64 and XR of the same 140 degrees is equal to 77.
Now that you kind of heard the computer voice, just listen again.
YR of 140 degrees is equal to 0.64 and XR of the same 140 degrees is equal to 77.
It was negative 77. I don't know why she didn't read it. Now, everything that was said there is true. Okay? It basically, they said y over r equals this and x over r equals that. It's all true. If I can just say with honesty but kindness that it's not making the connection. Maybe it's not getting to that significant idea. As I kind of already said, something about the unit circle. But it's all right. Okay? Again, I don't even know who it is, and it doesn't matter to me. Let's see what this is.
In comparison to the unit circle, the triangle formed between the reference angle has an x value of 77 and a y value of 0.64 in quadrant 2.
Okay, now I hear something. Okay, we're kind of getting some more statements here. The word unit circle is used. Okay, what exactly are these numbers? You heard someone say one's the x value and one's the y value. Okay, I'll share in genuine, honestly, that's getting closer as trying to make some connections. Listen to this one.
I think the 0.64 and 77 are locations on the unit circle. Think the 0.64 and 77 are locations on the unit circle.
Do you think that they are? Okay, well, they are. Okay, so what location are they on the unit circle? Those two numbers are location on the unit circle. So, like, what location?
The point on the unit circle, I love the unit circle, is found at minus 0.77, 0.64. The point on the unit circle, I love the unit circle, is found at minus 0.77, 0.64.
Now, do you realize what's starting to be said here? There's an actual point. In fact, the point was named, like, in the right order. Like, you can't be like, well, I assumed that. Okay, so like saying the actual point, negative 77, comma 64, is a point on the unit circle. Now, there's honestly just one thing missing. There's one thing missing from that. Listen, because this one kind of gets that missing piece.
This means that when an angle is equal to 140 degrees, the corresponding point on the unit circle is A minus 0.77, 0.64.
This means that when you have an angle of 140, that the corresponding point on the unit circle is negative 77,64. Okay. I said this isn't easy, but as you listen to that, are you starting to say, okay, yeah, even though we had these weird decimals, okay, that decimal referred to a point at 140 degrees on the unit circle. I know it's sometimes hard to listen and it's helpful to read. So this is kind of like Mr. Naylor's statement. Now listen, this isn't like what's the right answer. It's not like mine's the right answer, but we're trying to see all three of these things. You have an angle, it intersects the unit circle at that point. It might be something you want to write down. I'm just going to pause a second. It is going to be a test question. You know, if you're the kind of student that you can keep track of that stuff, I hope you are. Put a star beside it, put a box around it. Do you need to see the original question again? Okay, so we basically have this mathy statement. The sine of 140 is 0.64. The cosine is negative 77. Grab whatever you need to grab out of that. Maybe just what's in the call box there. Sort of curious, can you write the answer now? Again, if you can, you're going to be able to do it in a few days. So I like that I flip back to the screen because maybe now you have to write the answer yourself. I will show you, but if you kind of want to force yourself to try to think of that answer again. Anything else from this little different activity here? Now listen, when I checked the homework, I actually just checked that you tried it. But if you got number 10 right, yeah, I actually gave you a little bonus point. Okay, but if you tried the homework, you got the full credit. You don't have to worry about if something was wrong. But we always want to be trying to figure out how to do them right. I'm picking out number 10 because it's actually a little segue into today. Today we're going to do a little more of this. I actually have a practice paper I want to get in your hands sooner than later. But there's actually something about 10 that it's a little bit more, it has a little bit more thinking just because. Honestly, because the angle that you have here is tricky. Okay, I was impressed, though. A lot of you realized that, first of all, that it's really just negative 240. Okay, now, if you didn't get to that step, and just forgive me if you did and you're kind of like, I already got that, but you got to convert this. And of course, you got to remember how to do that. Go back to the pi over 180 ratio and then set up a proportion so that you can get something figured out with this negative 4 pi over 3. Do you remember that? A lot of you did, which is really good. A little cross multiply business here. You end up with pi x equals 180 times negative 4/3 pi. The pi's cancel. And I'm not into shortcuts much because we forget shortcuts, but it is true that you're really just going to multiply 180 times negative 4/3. 180 times negative 4/3 because the pi's cancel. Negative 240. Now, negative 240 is kind of what this problem is built around. And again, I'm impressed. A lot of you sketched it correctly. You sketch negative 240, you go this way. You go past negative 90, past negative 180, but not all the way to negative 270. So here's negative 240. Again, nice job. Now, at this point, you sort of can like bag all the negatives. Like, I guess what I mean is you don't have to like think that the triangle is going to have like a negative angle. The triangle is still the triangle. It has an angle here. This is the step where some of you, it went a little bit astray, but let's figure it out. We still have this angle right here. It's like the distance, it's like the difference between negative 180 and negative 240. Okay, now we've done this before. It's called the reference angle. So just kind of look at those numbers, a little compute, boom, 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 boom. The difference between these numbers is 60. 60. Okay, now be careful because some of you wrote a 30 right there. So now, your answers start to change. But do we have any questions why I'm putting a 60 there? It's pretty important. Okay, because that means that 30 goes up here. And, you're kind of back to, I hope, back to good old 30, 60, 90. You're back to thinking about the legs of this triangle. Okay, now across from 30 is the smallest side, 1. The hypotenuse is always 2. And then root 3 to wrap it up. Of course, there's one more thing to make this super duper. It's not 1, but negative 1. It's a negative dimension. All right. Now, it's hard to get these answers right if your sketch is wrong. I'm not trying to sound like negative, but it's just true. If your sketch is mixed up, then these are going to get mixed up. But now that it's written this way, tangent is y over x. So root 3 over negative 1. Be nice if you write it as negative root 3. Cosine is x over r. And then sine would be y over r. Robbie.
So for that one, I mixed up and I did since it's like a negative angle, I accidentally did it as if it was just a normal 240, but I still got the same answer. Is that always going to work out?
Was your triangle still here?
Yeah, but it was just that other way around. And it went like that way, except it was in like the third one.
Okay, that's what kind of was I wondering. So I think we have a little bit of, you sort of made 2 wrongs, made a right type thing. But seriously,
still 60 degrees.
Yeah. So let's say you kind of, you're being honest. You said, hey, it's just 240 maybe. So, your sketch is right here. It's still 60 degrees. Here's the thing. It's still 1, 2 root 3. There's one thing that would be different.
And it just worked out. Like, I think I made the one negative that should have been positive and the other one.
Okay.
Like, I think I just messed up twice and it worked out.
So, yeah, you maybe made 3 lefts and ended up at the right. But you figured out what was different by what you just said. If you really drew it down here, then both these would be negative. But as you said, you kind of dropped the negative. It's okay. I told you this problem is a little bit of a segue into today.
So will the 2, like for the hypotenuse side, will that ever be a negative?
It will never be a negative. The radius is like a distance. It's like a distance measured from the origin. So here's the thing. The x and y will give you the direction. But like I said, if I run 5 miles, I can run 5 miles any direction. but the X and Y will tell me if I went north, south, east, or west. Now, by the way, the answer to number 10, or maybe I should say the stuff you did in number 10 was actually just like number 5. Number 5 is actually the same problem. Is there anything else like on this paper? I saw some of you had some question marks. We got time. Usually we have a little more to talk about here. Go ahead.
Number 3.
So it's a negative. It's funny that you asked about number 3 because it's actually also kind of into what's going to happen today. It's a big negative, isn't it? Okay, now you can get like really dizzy if you want, trying to graph negative 750. I'll be honest, I get dizzy now. I can't get on rides that go in circles, so I don't want to spin around negative 750. So what I'm doing here is I'm adding 360 until I get somewhere that I kind of feel like I know. Okay, now you're allowed to do this because, of course, this place where this new angle stops is the same place where negative 750 stops. I decided to add 360 a couple times because as soon as I got to negative 30, and how about you? Do you feel like you know where negative 30 is? Okay, negative 30. Drop it down. Make your triangle. Pretty cool. You know right away that that's 30. Don't say negative 30. You know it's 30. And since you asked Chase, we can kind of go through this, but a lot of it ends up at this point being the same. Across from 30 is 1. Of course, it's negative 1. Both these problems actually fit into what we're going to do today, because what I'm going to do today is kind of give you problems that are a little harder, simply because the angles are a little less familiar. If the angle is a little less familiar, can we get it to be something familiar? The paper you're getting is kind of a little bit of some notes and then a little bit of practice. It's a little bit of notes, a little bit of practice. Now, at the top, I had a statement. Let's fill it in. I kind of have said this a little bit. We actually did it for the problem Chase asked about. So if I give you an uncommon angle, we'll just say it's something you're not familiar with. It might be helpful to try to think of something that you are familiar with. Like we call it a coterminal angle to kind of be technical. The coterminal angle is actually kind of what I did with number 3, where we add 360 until we get somewhere that we understand. So now, do you notice how letter A is a little different than your homework? I'm only asking you for the tangent. That's actually trying to make your life a little easier. Instead of asking you for the sine, cosine, and tangent, it's just the tangent, but you still do the same thing. You try to think about this angle. Okay, now this angle, negative 11 pi over 4, most kids want to turn it into degrees. So before I even think about something familiar, you got to switch this to degrees. Okay, remember, you can set up one of these ratios or proportions. I'll do it one more time. You can also use a little shortcut, because all that's really going to happen is you're going to multiply 180 times negative 11 fourths. 180 times negative 11 fourths comes out to negative 495. Make sure you play along. If you're good, that's good, but make sure you know how to get negative 495. This problem now boils down to thinking about that angle. Okay, but again, even for me, on the top of my head, I don't really know what's up with negative 495. It's a little too much spinning around, so I could add 360. If you do that, you get negative 135. Now, some students would say, okay, I'm good with negative 135. But just to show you, I could add 360 again, especially if I like things positive. Maybe I just like those kinds of numbers. Okay, so that's what I mean by a coterminal angle. And by the way, we also made it positive because we like things that way. The rest of this is just like what we did yesterday, but it's still good to go over it. We got to really carefully sketch 225, kind of like was mentioned in the homework in the correct quadrant, okay, because the quadrant is going to matter. Think about your triangle. Some people, the first thing that they do is actually think about this angle up here. Whatever kind of order you like to do this in, be careful. 180, 225, find the reference angle. Okay, as we said yesterday, it's always going to be a special triangle. So, you get 45, that should make you kind of happy because this is a special 45, 45, 90. That's the way it's supposed to be. How's the sides of these going? Are you kind of memorizing them? Don't want to use the word memorize too much, but you need to know that the sides of 45, 45 are a 1, 1 root 2. And be careful about the root 2. Don't mix it up with root 3 from the other triangle. Make these negative, right? I should have asked you guys, but make those negative. Very important. But, geez, after all that work, we're ready to do the tangent. And it turns out that the tangent is actually just x over, or y over x. So negative 1 over negative 1 is 1. But the work that we did was necessary to get to that point. I want to set you loose here, but let's do letter B first. Let's do letter B. Secant of 660. And again, 660, even when I look at that, I'm kind of like, where's that? What you really should do is you should find something coterminal. So subtract 360, get rid of the extra spin. Okay, so the problem now is all about 300 degrees. 300 degrees. We should like that because it's able to be found. We can make a triangle. We can get the reference angle. Okay, be careful, because when I write 60 up here, it's not because it's always 60. It's because it's the reference angle between 300 and 360. So I think you're realizing that that angle could be 30, it could be 60. Find it carefully. But how's the rest of your triangle? Give you a chance to think about it. You can compare your answer here. It's definitely a 1, 2, root 3 in this arrangement. 1 is across from 30, 2 is the hypotenuse, and of course negative root 3. Did you just memorize those definitions for the quiz yesterday? Okay, make sure it gets into your long-term memory. Secant is r over x, 2 over 1, 2. I want you to have a little bit of class time. Maybe you can work on half of these. Maybe you work through a few and you need some help, but I want you to have a little bit of time because I'm kind of curious if you need anything. I hope you'll ask if you do.